Okay, so safety engineering.
Uh-huh.
I'll admit, when I first saw that, it was like the topic for today,
Hmm.
I kind of thought, is this going to be like super technical?
Yeah, I can see that.
But then, like, getting into it, it's real. Honestly, it's way more interesting than I thought. It's kind of everywhere, right? I mean, think
Heck,
about
this
it.
really is.
A chair I'm sitting on, the buildings around us, the roads, everything, right? It's all got to be safe.
Yeah. Safety engineering, it's kind of like it often works in the background,
Right.
but it's really everywhere, and it's super important to our lives. So for this deep dive, we're looking at this safetyengineering.pdf. It's a pretty dense document.
Yeah.
So what we're going to try to do is, pull out the most important stuff, the really interesting parts,
Hmm.
and we really want to help you, the listener, to sort of get through this, all this information and really just get to what really matters.
Exactly. And without, getting bogged down in like super technical details, right? Just making you really clear.
Yeah.
So what's on the agenda today? Well, first, we're going to talk about what exactly safety engineering is and why it even matters.
Right.
Then we'll look at kind of how it developed over time. Like, how do we get to where we are today?
Yeah.
And then we'll talk about risk, which is a huge part of it, right? Like, how do you identify, how do you analyze, how do you manage risk?
It's really, really important. Yeah.
And then we'll get into the specifics, right? How is safety engineering applied in different industries? Like, how do they keep machines safe? What about electrical systems, chemicals, fires, construction sites, all that?
Yeah. And we'll talk about human behavior, which is a big part of safety too.
Right.
And we'll also look at the environmental side of things, the legal stuff, rules and regulations, and of course the importance of training.
Right.
We've even got some cool historical facts and like real world stories to keep things interesting, keep things real.
All right. So are you ready to dive in with us?
Let's do it.
Let's go. So first things first, what exactly is safety engineering? And like, why should we even care?
So at its core, safety engineering, it's kind of a mix of a bunch of different fields,
Yeah.
It uses the same principles that engineers use to design things, analyze problems, solve problems,
Right.
But the focus is on safety. It's about making sure things are safe for people, for property, for the environment.
So where do these safety engineers actually work? What kind of places?
Oh, they're everywhere. You'll find them in construction, making sure buildings are, sturdy and workers are safe. They're in factories, designing production lines that are, efficient but also safe.
Right.
They're in transportation, oil and gas, chemical plants, even robotics and renewable energy.
Wow.
They need safety engineers, too. It's all about building safety into things from the start and then, managing whatever risks are left over.
Okay. So it's not just about hard hats and, those reflective vests.
No, not at all.
So what are the main, the big goals of safety engineering? What are they trying to achieve?
Okay, so there's multiple layers to it. The
Yeah.
first one, the most basic, is prevention.
Okay.
Like stopping accidents from happening in the first place,
Yeah.
figuring out what could go wrong and stopping it before it does.
Right. Makes sense.
Then there's protection. So, if something does go wrong, how do you minimize the harm?
Okay.
So that's where things like, safety gear come in or, those fail-safe mechanisms in machines.
Gotcha.
Then there's compliance,
Mm-hmm.
making sure everyone follows the rules, all the laws and regulations about safety in different industries.
Right.
And last but not least, there's efficiency.
Oh, okay. That's an interesting one.
Yeah, so, accidents cause disruptions. Injuries mean people can't work,
Right.
and all that costs money.
True.
So by making things safer, you often make them more efficient, too. Less downtime, all that.
It's kind of like an ounce of prevention is worth a pound of cure kind of thing.
Exactly, yeah.
Okay, but besides preventing injuries,
Right.
which is obviously huge, why else is safety engineering so important?
Well, there are a few key reasons. Like we said, preventing accidents is paramount. And we're talking about everything from a small cut to, really serious injuries, even huge disasters.
Right, right.
Imagine a building collapsing or a big chemical spill. It's not just the human cost, it's the economic impact, the environmental damage. It's massive.
Absolutely.
So protecting people and the planet, that's a huge ethical responsibility for any organization, right?
Yeah.
Then there's the legal side of things. There are a ton of rules and regulations about safety. If
Right.
you don't follow them, you can get hit with big fines. You might even have to shut down. And then there's the damage to your reputation.
Yeah, nobody wants to work for or buy from a company that has a bad safety record.
Exactly. And lastly, having a strong safety culture, it actually makes people more productive.
Oh, how so?
Well, when employees feel safe, when they know their company cares about them, they're more likely to be engaged, you know?
Right.
They're not worried about getting hurt, so they can focus on their work.
Makes sense.
Mhm.
You mentioned earlier there were some interesting historical bits about this.
Oh, yeah.
Like, when did people start taking safety seriously?
Well, if you look back at the Industrial Revolution, it's kind of shocking.
Really?
Yeah, in the beginning, there was almost no focus on safety.
Wow.
I mean, they had child labor, people were getting killed by machines all the time.
Oh, that's awful.
It was terrible. Eventually, there was so much public outcry that they started passing the first labor laws,
Okay.
but it was very reactive, like something bad would happen and then they'd make a rule.
Right.
Now, fast forward to, more recent times, a big turning point was the Bhopal gas leak in 1984.
Yeah, a terrible disaster.
Thousands of people died, and many more have suffered long-term health problems. That really showed the world how important proactive risk management is.
Yeah, you can't just wait for something bad to happen. You have to try to prevent it.
Exactly. Bhopal led to a huge shift in thinking. It's not just about reacting to accidents anymore. It's about stopping them before they even happen.
So how did that shift happen? Like, how do we go from those early kind of basic responses to the more sophisticated approach we have today?
It was a gradual process.
Mm.
Like we said, the Industrial Revolution was kind of the starting point, not much attention to safety at first. Then, in the early 1900s, things started changing.
Right.
There were some really bad factory fires, like the Triangle Shirtwaist Factory Fire in 1911.
Yeah, I've heard about that. A lot of people died.
Over 100 people, mostly young women, trapped inside. That really pushed for better safety regulations.
Right.
After World War II, technology was advancing really fast,
Yeah.
and industries were getting bigger and bigger, so the focus shifted to system design.
What does that mean?
It means they started thinking about how to build safety into the design of things from the ground up.
Oh, I see. Not just adding it on as an afterthought.
Exactly. Then, the late 20th century, that's when we had those big industrial accidents like Bhopal.
Right.
Really tragic, but they pushed the field forward,
Oh, yeah.
They really highlighted the need for proactive risk management, finding hazards before they cause harm and figuring out ways to control them.
Mm-hmm.
And today we have all these amazing tools like computer simulations, data analysis,
Yeah.
really sophisticated ways to assess and manage risk.
That sounds like regulations and standards have played a big part, too.
Oh, absolutely. They've been really important drivers of progress.
You mentioned OSHA earlier.
Yeah, so OSHA, that's the Occupational Safety and Health Administration in the U.S.
Right.
It was created in 1970, and it's been a big deal.
Okay.
They set and enforce workplace safety standards for all kinds of industries.
So they're like the safety police.
Kind of, yeah.
What about globally? Are there any international standards?
Yeah, a big one is ISO 45001.
ISO 45001.
Yeah, it was introduced in 2018, and it's a global standard for occupational health and safety management.
Okay.
What's really cool about it is that it focuses on being proactive, not just reacting to problems, but actually trying to prevent them.
Mm-hmm.
So companies have to actively identify risks, put controls in place, and always be looking for ways to improve their safety performance.
That makes sense.
Yeah.
What about in India specifically?
Well, in India, you have the Bureau of Indian Standards, or BIS.
BIS.
Yeah, they develop national standards, including safety standards.
Okay.
Like IS 14489 for safety audits and IS 1801 for managing health and safety.
Gotcha.
And these standards often line up with Indian laws, like the Factories Act of 1948.
So they kind of work together.
Yeah, exactly. And then there's the International Labor Organization, or ILO, which is part of the UN.
Right.
They create international labor standards, which are basically agreements about workers' rights and safety.
Okay.
And those influence national policies in a lot of countries. And in Europe, you have EU OSHA. They work on promoting risk assessment and best practices for safety in all the EU countries.
So there's a lot of effort going on at different levels to make workplaces safer.
Yeah, for sure. And all these standards and regulations, they help to create a more consistent and systematic approach to safety.
That's good. But how do safety engineers actually prevent accidents? It seems like understanding risk is a big part of it.
You're absolutely right.
Okay, so walk me through that. Like, how do they decode risk?
Well, it's usually a three-step process. First, you identify the hazards.
Okay.
Then you analyze them. And finally, you control them.
Gotcha. So first step, hazard identification.
Exactly. That's basically figuring out what could potentially cause harm.
Okay.
These hazards, they can be physical, chemical, biological, or ergonomic.
Okay, can you give me some examples of each of those?
Sure. So physical hazards, that could be like, a machine with moving parts that aren't guarded,
Right.
or a slippery floor that could cause someone to fall, or working at a height, like on a roof.
Okay, makes sense. What about chemical hazards?
So those are things like toxic gases, corrosive liquids, flammable materials, things that could, poison you, burn you, or start a fire.
Gotcha.
Biological hazards, those are usually related to living organisms like bacteria, viruses, or mold.
Right.
You find those a lot in healthcare settings or, places that process food.
Makes sense. And then ergonomic hazards.
Those are about how you interact with your work environment.
Okay.
So, like, if you have a poorly designed workstation or you're doing repetitive tasks, you could develop injuries over time.
Right, like carpal tunnel syndrome or back problems.
Exactly.
So how do safety engineers actually identify these hazards?
There are a few ways. They do inspections. They walk around and look for potential problems.
Right.
They read safety manuals. They look at reports of past accidents to see what's happened before.
Yeah.
They might monitor the air quality to make sure there aren't any dangerous substances in the air. And they also do ergonomic assessments where they look at workstations and how people are using them.
So once they've identified the hazards, then what?
Then they move on to risk analysis.
Okay, so what happens in that stage?
So this is where they figure out how bad the consequences could be if a hazard actually caused an accident.
Right.
And they also try to figure out how likely it is that the hazard will actually lead to an accident.
Okay.
There are two main approaches to this: qualitative and quantitative.
Okay, what's the difference?
So qualitative analysis is more about using your judgment,
Mhm.
thinking about the hazard and deciding if it's a low, medium, or high risk.
Okay.
They often use a risk matrix for this. It's basically a table that helps you visualize the risk.
So like if a hazard could cause a really bad accident, but it's very unlikely to happen, it would be a high severity but low probability risk.
Exactly. And the matrix helps you decide which risks need the most attention, which ones need to be addressed first.
Makes sense. And quantitative analysis.
So that's more about using number and data.
Okay.
So they might analyze data from past accidents to see how often certain types of accidents happen.
Right.
Or they might use more complex methods like fault tree analysis or event tree analysis.
What are those?
But those are basically ways of modeling how different events could lead to an accident.
Oh, okay.
It's like you map out all the possible things that could go wrong, and then you try to calculate the probability of each one happening.
That sounds pretty complicated.
Yeah, it can be, but it's really important in industries where the consequences of an accident could be catastrophic.
Right, like nuclear power plants or airplanes.
Exactly.
So once you've analyzed the risks, what do you do about them?
That's where risk control comes in.
Okay, so what does that involve?
It's all about finding ways to reduce or eliminate the risks you've identified.
Right.
There's a hierarchy of controls, which basically tell you which control methods are most effective.
Okay, so what's at the top of this hierarchy?
The best solution is always to eliminate the hazard completely.
Okay, but that's not always possible, is it?
No, unfortunately not. But if you can get rid of the hazard, that's the ideal.
Right.
If you can't eliminate it, the next best thing is substitution.
Substitution.
Yeah, so that means replacing the hazard with something that's less dangerous.
Okay, can you give me an example?
Sure. So let's say you're using a really toxic cleaning solvent.
Mm-hmm.
Substitution would be finding a different solvent that cleans just as well but isn't as harmful to people.
Gotcha. So what if you can't eliminate or substitute the hazard? What's the next best thing?
Then you move on to engineering controls.
Engineering controls.
Yeah, so those are about making changes to the work environment or the equipment itself. Like
Right.
you might install a ventilation system to remove dangerous fumes,
Right.
or you might put guards on a machine to prevent people from getting their hands caught in it.
Makes sense.
If engineering controls aren't enough, then you can use administrative controls.
What are those?
Those are about changing the way people work.
Okay.
So you might create a safe work procedure that everyone has to follow.
Right.
Or you might provide training so people know how to work safely.
Oh, I
Or you might limit how long people can be exposed to a hazard.
gotcha. So what's the least effective control method?
The last resort is personal protective equipment, or PPE.
PPE.
Yeah, so that's things like hard hats, gloves, safety glasses, respirators.
Right.
It's basically the last line of defense. It protects the individual worker, but it doesn't actually get rid of the hazard.
Right.
So it's not as effective as the other method.
Makes sense.